Whoever invented the electric kettle was a genius. I'm sure you've all used one of these kettles before. So, do you know how it boils the water? First of all, here's the body of the kettle that holds the water. On the handle at the back, you can see a button. This is the control switch. When you press it, it will start to heat up. At the bottom of the kettle, which is also an important part of the kettle, this is where the heat is generated and transferred. To avoid overheating, there is an overheat switch underneath. Here is the connection between the live line and the neutral line. This connector is just enough to plug into the base underneath. So why does the switch turn off when the water boils? The key lies in this metal sheet. It's actually a combination of two different metal sheets. These are two metals with different rates of thermal expansion, like aluminum and copper. But they have similar physical elasticity. Simply put, they stretch or bend differently during the process of thermal expansion and contraction. If you stack two materials, then when the temperature rises, the material with the higher coefficient of thermal expansion will bend more than the other material. Then they'll bend towards the lower side and the other way around. So what does this have to do with boiling water? Well, we all know that when water is boiled, it starts to boil, and it produces a lot of hot steam. This steam flows along the bottom of the vent and reaches the switch. Then the metal plate on the switch is affected by the steam and its temperature rises. Once the temperature reaches a critical level, they begin to bend and deform. As you can see in the diagram, there's a lever on top of the metal plate. There is also a lever at the back of the wire joint. As the sheet bends, the lever in front is pushed up, and the rear lever is pushed down, so the switch closes automatically. The following overheat switch works in the same way as the one above. The only difference is the temperature setting. The lower overheat switch sets the temperature above 100 degrees. Otherwise, the water will not boil. This switch is usually off. Only when the bottom of the kettle is overheated, it will trigger the work. Here we can see a column. Once the temperature exceeds the limit, the metal plate starts to bend and deform. The pressure pushes the metal underneath the cylinder down, disconnecting it. And that breaks the circuit. It's worth noting that if the overheat switch here is triggered, the kettle will have to sit for a long time before it can boil again. And on the side of the kettle, we can see a red indicator light. It's connected to the circuitry at the bottom of the kettle. When it's on, it means it's working. And when it's off, it means the water is boiling. And finally, the lid of the kettle. You can press it down when you fill the kettle. When you open it here and press it down, you'll hear a click. That's because there's a snap on the inside of the lid and a spring at the back. When the lid is closed, the spring releases and the clasp hits the kettle with a click. When you press the top button, the spring loads and the front catch releases. Lift the lid and you can fill the kettle.